So here in our example, we have to find out the inverse of matrix. Okay, so I consider this example. So similar type of the examples are coming for your board exam for 4 marks. Okay, so here I consider the example A inverse which is equal to 2 minus A which is equal to 2 minus 1 1 minus 1 2 minus 1 and 1 minus 1 2. Here we have matrix A, and we have to find out the A inverse. Okay, using adjoint method. That same example asked for your board exam for 4 marks. Okay, so similar examples coming for your board exam for 4 marks. So we need to find out the only inverse of matrix. Okay, using adjoint method. That means first of all we have to deal with minor, then it's a cofactor, and once we get the cofactor, then take the transpose of cofactor, you will get the adjoint matrix. Okay, so once we get the adjoint matrix, we substitute that value in the formula. So what we have the formula for finding A inverse? So A inverse can be written as 1 upon determinant of A into adjoint of A. Okay, so adjoint of A it is there. So this is the way we can find the A inverse of our matrix. Okay, so matrix A it is here, and using that we have to find out the A inverse. Okay, so we want the adjoint of A. So first of all we have to find out the determinant of matrix. Okay, once we come to understand the determinant, which is a non-zero. Okay, once determinant is a non-zero means matrix is invertible, then and only then we say the inverse of a matrix exists there. Okay, so for finding their determinant, find out the determinant of A. Okay, so what we will get the determinant of A? So determinant of A can be written as 2 into under bracket. Now we have to solve the matrix only, so you will get the determinant. Okay, so determinant of A, go for the finding determinant. 2 common here, 2 2s are 4. Okay, minus of minus, it goes to plus and minus 1. Okay, so 2 into 4 minus 1, again minus of minus 1, it goes to plus. So under bracket will remain here minus 1 into 2, which is a minus 2, and minus 1 into 1. Okay, so minus 1 into 1, minus of minus plus 1 it is there. Okay, and then with respect to last element plus 1, take this 2 by 2, minus 1 which is coming as 1, and 2 into 1 minus 2. Okay, so this is the value for our determinant of A. If you're going to find out the calculation for this, you will get the determinant of A as a 4. Okay, and which is equal to non-zero. So if we have determinant non-zero, then and only then we can proceed further for finding its inverse. Okay, whenever the determinant non-zero it is coming, then we say that the inverse of matrix exists there. Okay, now let's find out the inverse of matrix. Okay, so we come to understand the determinant, which is a 4. Okay, now for finding the inverse, first of all we have to find out the minor. Okay, because we have to substitute that matrix minor into the cofactor matrix. Okay, that we use minus 1 raised to I plus j into minor of ij. Okay, so Cij formula it is there. Okay, so here minor of ij, that means we have to find out the minor for each and every element of our matrix. Okay, so now start from the 2. So minor of 2, minor of A11. Okay, A11 which is equal to 2. Okay, so we want the minor of A11, and A11 element it is here 2. Okay, so we want the minor of 2. So minor of 2, it gives us the 2 by 2 determinant here. Okay, so 2 minus 1 minus 1 2. Okay, this is a 2 by 2 determinant for our minor. So once we solve this one, so we'll get the 4, again minus of minus plus 4 minus 1 it is there. Okay, so we'll get the 3. So here we can see that we multiply this 2 into 2, it comes 4, minus of minus 1 into minus 1, it comes plus, that means 4 minus 1, which is a 3. Okay, so which gives the M11. Okay, minor of first element. Okay, so we got the minor of first element M11, which is a 3. Similarly, do it for A12, minor of A12. Okay, now what is the element A12? First row, second column, minus 1. So with respect to this, find out the 2 by 2 determinant. So what we do, we make the bracket for that minus 1. So we'll delete that bracket from here. The left element minus 1, 1, 2, minus 1, 1, 2 are the minor for matrix. Okay, so minus 1 into 2, it gives minus 2, and a minus of minus plus 1. Okay, so it goes to the minus 1. So we got the minor of A12 which is a -1. Okay, so we have here minor of 1, 2. Okay, which is a -1. Similarly, we have to follow the same procedure for the other element till the A33. Okay, now let's go for the minor of A13. Okay, next minor of A13. Okay, so A13, which is 1. Okay, so we want the minor of 1. So what we get the minor? So delete this complete row and column. So you will get the -1 to 1 -1. Okay, -1 to 1 -1. Okay, find out that this determinant 1 minus 2, which gives us -1. Okay, so this is the minor of 1, 3. Okay, similarly, we can find the minor for remaining element. Okay, let me whip it out. Now here we can go for the similar process to the other element. So if we want the minor of A21, okay, so minor of A21, okay, minor of A21. So what is the A21 element? Which is a -1. Okay, so it is a minor of A21, which is a -1. We want the minor for that -1. So what we do? We create the 2 by 2 determinant with respect to that element. Okay, so we have -1. So create here a bracket for this -1. Okay, so delete this bracket. That way I did it here, and the remaining leftover values -1, 1, -1, 2 are the determinant here. Okay, -1, 1, -1, 2. Okay, this is a 2 by 2 determinant, gives us a minor for third element. Okay, so solve this one. -2. Okay, minus of -1 plus 1. So we'll get the -1 as the minor of 2, 1. Okay, this one is the minor of 2, 1. Okay, which is a -1. Similar, we have to follow the same procedure for the other element. Okay, so we can go for the element 2 here also. Okay, now for finding the minor of 2, that means A22, so we make the square bracket for it. Complete that square bracket as a row and column. Now as I done here. Okay, so what we do? We delete this entire row and column. Okay, so the leftover element 2, 1, 1 and 2, we have to take that element as a minor for next element. Okay, I hope you all have understood the part of minor. Okay, similarly do it for the other element. You will get the required matrix. Okay, so I'm not gonna explain the remaining part here, so you may have to go for the calculations. Okay, it is easier part. Okay, I hope you all can do this. Even after, if you found anything difficult, let me know in my comment section. I will come up with the more videos. Okay, so here in my next part we got the minor. Now using minor we want the cofactor matrix. Okay, so try to build the cofactor matrix. So cofactor matrix, how it look like a Cij. We can write cofactor matrix as a C11, C12, C13. As before, we are taking A11, A12, A13. Instead of that, we have taken C11, C12, C13 and so on. Okay, just replace the cofactor matrix. Okay, C21, C22, C23, C31, C32, C33. Okay, so we have to build this cofactor matrix. Okay, once we get that cofactor matrix, take the transpose, you will get the adjoint of matrix. Okay, now here what we do, find out the C11 using this formula. Okay, C1 means here we gives us I which is equal to 1 and j which is equal to 1. Now compare that C11 with the Cij. Okay, that means I gives us 1, j gives us 1. Okay, that means we'll get the -1 raised to I plus j, that means -1 raised to 1 plus 1. Okay, and to minor of 1, 1. Okay, minor of 1, 1. What I have done, I replace I as a 1 and j as a 1 in this entire formula. Okay, and go up, use the minor of 1, 1 as we have here, it is a 3. Okay, substitute here. Now here -1 raised to 1 plus 1, that means -1 to the power even number like a 2, 4, 6, 8, it always goes to positive. And -1 to the power odd number 1, 3, 5, 7, it gives us negative value. Okay, remember this one. So -1 raised to 2, it gives us 1, and minor of 1, 1. Okay, minor of 1, 1, what we have here, 3. Okay, that means C11 I found here 3. Okay, I hope you all have understood first element for our cofactor matrix. Okay, now put all these elements here. Okay, so you may write this cofactor matrix here. Okay, you can see first element C11 I found it here 3. So cofactor of A, okay, cofactor matrix A I written here, okay. This one is the cofactor matrix. So first element I found it here 3. Now similarly go for the C12, that means minus 1 raised to, now I which is equal to 1 and J which is equal to 2, okay. So we have to compare C12 with respect to Ci J. So you will get the value for I and you will get the value for J, okay. So I which is equal to 1 and J which is equal to 2 and minor of 1, 2, okay. So minus 1 raised to 3, that means the negative number is having odd power and it always gives us the negative value. Very good, okay. So here it gives us negative 1 multiplied by minor of 1, 2, okay. So which is also negative 1, okay. So negative 1 multiplied by negative 1, it gives us 1, and which is the value for C1, 2, okay. I hope you all have understood the value here, okay. So we got the C12 as a 1, okay. Now put it here. Now do it for C13. First row, third column, minus 1 raised to 1 plus 3 into minor of 1, 3, okay. So minus 1 raised to 1 plus 3 means it goes to 4, and minus 1 raised to even power, it gives us positive number, okay. So it gives us 1 only, and a minor of 1, 3, which is a minus 1, okay. So minus 1 into 1, it gives a minus 1, and which is the element for C13, okay. So which is a minus 1. So put it here, minus 1 here, okay. Now let's go for the C21. Minus 1 raised to, now I which is equal to 2, J which is equal to 1, okay. Now put it here, 2 plus 1 and minor of 2, 1, okay. Now minus 1 raised to 2 plus 1 again goes to odd power, it gives us minus 1 and multiplied by minor of 2, 1, which is a minus 1, okay. So minus 1 multiplied by 1, minus 1, it gives my 1, okay. This is a C21. So I got the value for C21, which is a 1, okay. Now put it here, C21, 1, okay. Now let's go for the C31, okay. Similarly, you have to find out the C21, C22, C23, C31, C32, C23, C33, okay. Similar process you have to apply for finding its minor, okay, and then you will get the cofactor of a matrix, okay. So as I feel that the example, the next part is easier for you all, okay. So I'm not gonna explain this part here. You may do it this calculation by yourself, okay, because we have to go for more example that can be helpful for us. Okay, so do that calculation, remaining left over calculation by yourself. Even after, if you found anything difficult, let me know in comment section, okay. Now write down the next remaining value. You will get the 3, 1 minus 1, 1, 3, 1. You will get the 1, 3, 1 here, okay, and minus 1, 1, and 3 it is there, okay. So this is the cofactor matrix. I got it here, okay. I got this cofactor matrix, okay. So this is the cofactor matrix. When we take the cofactor matrix transpose, you will get the adjoint of a matrix, okay. Now this is the part of the final solution, okay. Now we have the cofactor matrix. When we take cofactor matrix transpose, then we'll get the adjoint of matrix, okay. So adjoint of matrix. Now take the transpose. How we take the transpose? When we have rows, we convert it into the column, and when we have column, we convert it into the row. This is the cofactor of matrix, okay. Now convert it into the column rows. So we'll get the 3, 1, minus 1, okay, 1, 3, 1, 1, 3, 1, and minus 1, 1, 3, okay. So this is the our required adjoint of matrix A, okay. So we got the adjoint of a matrix A. Now for finding its inverse, it is quite easier, okay. For finding the inverse, what we do? We use A inverse, which is equal to 1 upon determinant of A into adjoint of A, okay. So we have this standard result. We need to substitute the value in this result, okay. So A inverse, which is equal to 1 upon determinant of A. What is the determinant of A? We have the determinant of A, which is we found it earlier, 4, okay. 1 by 4 it is there, okay. 1 by 4 it is the 1 upon determinant of A is a 4, and multiplied by adjoint of A. So multiply its adjoint of A, 3, 1 minus 1, 1, 3, 1, 1, 3, 1, and minus 1, 1, 3, okay. So this is the complete inverse of our matrix A, okay, which is the A inverse. I hope you all have understood how to finding the process for A inverse using our matrix A, okay. So we have given a matrix A and we need the inverse, okay. Quite easy part is that one. Just we need to apply some of the basic concept and the one standard result for cofactor of matrix, okay. Then you will get the our required answer, okay. Now you all have understood all this part. Let's move for the one another example, okay. That will be the more useful for you all to understand this concept, okay. Okay, now let's go for the one more example. In my next example, I have taken one standard matrix, okay. As you can see that lower diagonal element of our matrix is a 0. That means we consider it is the upper triangular matrix, okay. What is meant by upper triangular matrix? Whenever we have below diagonal element is a 0, then we consider as the upper triangular matrix, okay. So whenever we have upper triangular matrix, then it is more easier to find out their determinants, okay. For finding their determinants, we have to multiply only their diagonal elements, okay. So first of all, we have to find out the determinant of matrix. Once it come non-zero as an invertible matrix, then we'll proceed further for their inverse, okay. So we have A. So determinant of A we want it here, okay. So for finding the determinants, we know that whenever we have diagonal matrix, okay, like upper triangular or lower triangular or diagonal matrix, we multiply their diagonal elements, okay. So determinant of A, what we will get? The 1 multiplied by 2 multiplied by 5, okay. So it gives us 10, okay, and which is non-zero. So if it is a non-zero, then our matrix is a invertible. We have matrix invertible. That means our matrix is a non-singular, and whenever matrix is invertible, then only proceed for finding its inverse, okay. So next part is there to find out the Cij matrix, okay. Cij matrix, I explained it earlier, okay. What is the Cij matrix? C11, C12, C13, C21, C22, C23, okay, C31, C32, C33, okay. This is the Cij matrix, okay. No, let me make it here more correct. C2, 3, okay. This is the Cij matrix. We have to find out that cofactor matrix, okay. Cij means it is a cofactor matrix, okay. For finding the cofactor matrix, we know that we use the Cij as a minus 1 raised to I plus j into minor of ij, okay. This result we use for finding their inverse, okay. Now Cij will go for this one. So okay, I hope you all have understood this one, okay. And for finding the inverse, we have one more standard result, which is 1 upon determinant of A into adjoint of A, okay. So that means we have one more result, A inverse, which is equal to, okay, we have A inverse which is equal to 1 upon determinant of A into adjoint of A, okay. This part we have to find out here, okay. So for finding the inverse, so we know that determinant it is a 10, which is non-zero, okay. Then we'll move for the directly for finding the adjoint of our matrix, okay. Now here, so we have matrix A. Let's go for first of all finding their minors, okay. Once we come to get the minor, then it is easier to find out its cofactor, okay. So minor of each and every element we needed here, okay. So we want the minor, okay. So minor of A11. What is the A11 element? 1, okay. So we want the minor of 1. So make the bracket for 1, okay. This is complete bracket for 1. Delete this entire row and column. So the left element here 2, 4 and 0, 5, okay. So we have this one left element, okay. So 5 2s are 10, okay, and 0 into 4 it goes to 0, okay. That means our left element here as a minor of 1 1 as a 10, okay. So we got the minor of our matrix first element is a 10, okay. Now similarly go for the minor of 1 2, okay. Minor of A12, okay. So A12 element it is there 2, so we want the minor of a 2, okay. So we'll take the 2 by 2 determinant for this 2, which get the 0 4 0 5 0 4 0 5, okay. So when you're going to find its determinant, you will get the 0, which is the minor of second element, okay. Do it for next minor of A13, okay. Now A13, what we have 3 here, Okay, so we want the minor of A13. Okay, we want the minor of A13. Okay, so what the matrix will get for the A13? Now see that 3 using these 3, make the brackets. Okay, delete entire row column, you will get the 0 2 0 0. Okay, 0 0. Okay, so when you go for the finding their determinant, you will get the value 0, so which is a minor of 1 3. Okay, so this is a minor of a third element. I hope you all have understood this part. Okay, and not that difficult. Just need to find out the minor for each and every element. You can go for the second also, third also. So what we'll get the next minor? Minor of here we want the minor for that is 0. Okay, minor of A21. Okay, A21, which is the element here 0. We want the minor for it. Okay, so here third element is there. Now 0, we want the minor for A21. So which is the 2 by 2 matrix we will get for A21. Okay, so let me explain how can we build a 2 by 2 determinant here for finding their minors. Okay, now we can see here we want the minor of A21, that means we want the minor of that 0. So make the bracket for that 0 element. So you have to follow the same procedure for the remaining all elements. Okay, so make the bracket for this 0 and extend that bracket for upside horizontally and vertically. Okay, you have to expand it, so you will get this way. So delete entire row and delete entire column which contain that element 0. Okay, that means that a particular element. So the left element 2 3 0 5. Okay, so we will get the 2 3 0 5. Okay, you need to understand the sequence. How can we apply the sequence of our determinant? Okay, you don't have to take the random element, you have to take the element 2 front 3 and below 0 and front 5. Okay, so go for the finding their determinant. 5 to the 10 minus 0, so it is the 10, which is a minor of 2 1. Okay, so this is the minor of second row first column. Okay, similarly you can find the minor for the other element too. Okay, now let me explain for one more element. Okay, so we'll go for finding the minor of A22. Okay, because this is the middle number, and how can we make a 2 by 2 determinant using 2 2. Okay, so minor of we want next minor of A22. Okay, what is the element A22? Which is a 2 here. Okay, so we want the minor of A22, that means it is a some sort of a 2 by 2 determinant it is there. Okay, so what we do, we make first of all bracket for that 2. Okay, once we make the bracket, extend that bracket horizontally and vertically. Okay, so I extended this bracket here this way. Okay, so we'll get this like this. Okay, okay, I extended this bracket upper side, lower side, left, right, all the sides. Okay, now what we do, we'll delete this bracket. Okay, I deleted it. The leftover element other than deleted. Okay, other than deleted element, so we'll get the 1 3 0 5. Okay, 1 3 0 5. Okay, we want the sequence as 1 3 0 5 as it is, need to put there in a determinant. Okay, 5 ones are 5 minus 0, we'll get the 5 as a minor of 2 2. Okay, I hope you all have understood the minor. Okay, how can we find the minor for each and every element? Okay, do this similar process for all remaining elements. Okay, I'm just gonna explain only few elements here because all are having same procedure for finding their minors. Okay, so we have to go with the same procedure. So what you need to do remaining one by yourself. Even after if you found anything difficult, let me know in the comment section. Okay, now what we do, we have our next task is that to finding their cofactor. Okay, using minor. So what we get, the cofactor matrix C11, C12, C13, C21, C22, C23 and remaining element. Okay, so first of all we have to find out the C11. Okay, so put that C11 in our standard cofactor result. Okay, so C11 will get here minus 1 raised to 1 plus 1. Okay, into minor of 1 1. Okay, so what I have done, I replace I as a 1 and j as a 1. Okay, in our Cij. Okay, now we have C11 minus 1 raised to 1 plus 1 into minor of 1 1. Okay, minus 1 raised to even number always gives a positive value. Okay, minus 1 raised to even number gives us the positive value, and a minus 1 raised to odd number gives us negative value. Okay, we have seen already in our previous part. Okay, so minus 1 raised to 2 always goes the positive number 1. Yes, and minor of 1 1, what we have minor of 1 1, we can see here minor of 1 1 is a 10. Okay, so 10 multiplied by 1, it is a 10. Okay, so we got the first cofactor matrix. Okay, what we have cofactor matrix C1 1, first element it is a 10. So let me write that cofactor matrix here, that can be easier to you all. Okay, so we'll write a cofactor matrix front here. Okay, so this is the cofactor matrix that we got the first element C11. What is the C11? Which is a 10. I replace C11 as a 10. Okay, now similarly go for the C12. Okay, so we have to find out the next element, C12. Okay, C12, which is equal to minus 1 raised to 1 plus 2 into minor of 1 2. Okay, so minus 1 raised to 1 plus 2 means minus 1 raised to odd number like minus 1 raised to 3, and whenever it is odd coming gives us negative value. Okay, multiplied by, now minor of 1 2, what is the minor of 1 2? Which is a 0. So minus 1 multiplied by 0, it gives us a value 0. So we got the second element for cofactor, which is a 0. Okay, now go for the third element for cofactor, C13, which is a minus 1 raised to 1 plus 3. Okay, into minor of 1 3. Okay, so minus 1 raised to 4, it gives 1, multiplied by 0, it gives us 0. Why 0? Because minor of 1 3 we have 0 here. Okay, now put that 0 here. Okay, now let's go for the next C21. Okay, minus 1 raised to 2 plus 1. Okay, and a minor of 2 1. Okay, so minus 1 raised to 3, it is a minus 1, and a minor of a 2 1, what we have minor of a 2 1, which is a 10. Okay, now multiplied by 10 here, we'll get the minus 10. Okay, so we got the minus 10 as a minor of a cofactor for C21. Okay, so minus 10 it is here. So similarly we can go for the C22. Okay, what we will get the C22? Minus 1 raised to 2 plus 2 into minor of 2 2. Okay, so minus 1 raised to 2 plus 2, it gives us a value 1, multiplied by minor of 2 2, it is here 5. Okay, so we get the minor C22 as a 5. Okay, I hope you all have understood all this entire process. Okay, remaining for C23, C31, C32, C33, you have to apply similar process like this one. Okay, so I'm expecting that you all have to go for this calculation. I'm just gonna explain only the part here which you need to understand. Okay, so remaining values, it comes like as a, now you can see that here minus 10 minus 10, and then remaining element you have to write as it is. Okay, so we'll get the next element as a 2 here. Okay, then after that 0 5 minus 4. Okay, we'll get the next element 0 5 minus 4. Okay, and we get the 0 0 2 as our cofactor matrix. Okay, this is our cofactor matrix that you can do it by yourself. Okay, the remaining remaining part here just need to apply same properties as we have done here. Okay, so I hope you all have understood this part. Okay, in our next part, what we do, we take that cofactor matrix and then we take the transpose. Okay, transpose of a cofactor matrix. Why do we get the transpose of cofactor matrix? Okay, when we take cofactor matrix transpose, we get the adjoint of matrix. Okay, okay, so adjoint of matrix that take its transpose, what will get the value 10 0 0, after that minus 10 5 0. Okay, so let me write this one as, okay, transpose means we have to convert row into column, column into row. 10 0 0. Okay, 10 0 0 minus 10 5 0 2 minus 4 and 2. Okay, 2 minus 4 or 2. This one is our required answer. Here it is a negative 4 is there. Okay, so this is our adjoint of our matrix A. Okay, now for finding the inverse, we use 1 upon determinant of A into adjoint of A. Okay, so A inverse we can write it as the 1 upon determinant of A into adjoint of. Okay, so what is the 1 upon determinant of A? Determinant of A we found it earlier. So 5 to the 10. Determinant we have here 10. Okay, so we found that determinant here. So we'll get the 1 upon 10 multiplied by adjoint of matrix 10 minus 10 to 0 5 minus 4 0 0 2. Okay, So this is our required inverse of our matrix. Okay, so the inverse of matrix A, we have found it here, 1 upon 10. Okay, so we got the inverse of matrix A inverse, which is equal to 1 upon 10 multiplied by under this 3 by 3 matrix. Okay, so this is the matrix. If you wanted to verify this matrix, what do? You just substitute this value A into A inverse and check it out whether it is gives us identity matrix or not. Okay, so for the verification purpose, you may have to use this formula. It is not that difficult. You can understand it very easily. Okay, easy part is that one. Okay, so I hope you all have understood everything for my today's lecture. Even after you found anything difficult in my lecture, let me know in comment section. I will come up with the similar videos. Okay, so thank you everyone. Thank you for my today's lecture.